Okay, so here's the study guide for questions 41 through 50. And I've got each of these matched out to match the question that goes with the study guide. All right, so on number 41, you have triangles that are cut by an angle bisector. And so we have two triangles. So this is our first triangle, and this is our second triangle. And so we have to talk about what matches with what. Well, we know 16 matches with 8, so we can set this up as 16 over 8. All right, and that's equal to 20 also matches with x, so 20 over x. And so when we go work this out, all right, we get 20 times 8, which is 160, equals 16 times x, which is 16x. And we divide by 16, and we get that x is equal to 10. You could also realize that 16 divided by 2 is 8, so 20 divided by 2 would have to be 10. All right, so that's just a couple of ways that we could go about doing that problem. Okay, 42 asks for if two shapes are similar. So in order for shapes to be similar, they need to have the same angles, which we have here, all right, and here, and their sides need to be proportional. So the angles checks out. Now we need for their sides to be proportional. So 15 over 30, all right, needs to be the same as 12.5 over 25. All right, and if we simplify both of those fractions, 15 over 30 is 0.5, and 12.5 divided by 25 is also 0.5. So both of them gives me 0.5, so I know that the sides are proportional. All right, sides are proportional, which means that yes, they are similar because the angles are the same and your sides are proportional to one another. Okay, 43 and 44 tells you to use the Pythagorean Theorem. And remember, the Pythagorean Theorem is a squared plus b squared equals c squared. All right, where a and b are your legs in the triangle, so they're always opposite, they're always attached to the L right there, and we said that your abs are attached to your legs. So A and B are going to be attached to those legs, which means that your hypotenuse, all right, your C, is always across from that L. Okay, so what we have to think about is we have A, we got B, and so X has to be C in this example. So plug it into our formula, 3 squared plus 4 squared is equal to x squared. All right, 3 squared gives us 9, plus 4 squared gives us 16, equals x squared. These two added together gives me 25, equals x squared. And then what we're going to do is take the square root of both sides and get that x is equal to 5 in this case. Okay, now in the 44 example, this time we're not looking for the hypotenuse. This time we're actually looking for one of the legs. So here's A and B. So I'm going to let A be x and B be 12 and C be 13. So I've got x squared plus 12 squared equals 13 squared. And so when we work this out, x squared plus 12 times 12 is 144, equals 13 squared is 169. And from here, I've got to subtract 144 from both sides. And we get x squared is equal to 169 minus 144 is actually 25. And here again, when you take the square root, you get that x is equal to 5. So in both of these cases, x is equal to 5. One was the hypotenuse method, and one was finding one of the legs in this case. But you're always using a squared plus b squared equals c squared when I'm only trying to find one missing side in a right triangle. Okay, moving on. Let's say I only know a side and an angle. All right, a side and two of the angles, technically, the 90-degree angle and one of these other angles. For this, I know I'm going to have to use the trig. So I'm going to have to use sine, cosine, or tangent. Okay, so we're going to go through and we're going to use kind of our same idea. We know that's A and B, so my hypotenuse here, all right, is where the 12 is. I always, every single time, mark across my angle, and that will take me to my adjacent side, which is A, which means that this is the opposite side. So we think about, what do we have? We have the hypotenuse and we have the adjacent side. So I have H and I have A. So which one of my trig ratios deals with H and A? All right, and I look and it is cosine. So I'm going to take the cosine of my angle, 40 degrees, equals A over H, which is X over 12. Okay, so I'm going to take the cosine of 40, put that in my calculator. All right, we get 0.766 equals X over 12. And now all I have to do, guys, is just cross multiply. So I take my 0.766 times 12, and I get that X is equal to 9.19. Okay, so that would be one example. All right, let's look at this second example. Okay, and again, let's first label the hypotenuse. So the hypotenuse is over here at 13. Again, I'm going to mark across my angle, the 58. That's going to take me to my adjacent side. So this has to be my opposite side. So what do we have? We have the hypotenuse, all right, and we have the opposite side. So I have H and I have O. So if I go look, H and O, that is sine. So I know that I'm going to have to pick sine for this problem. So the sine of my angle is equal to O over H. So in this case, all right, we have the sine of 58 equals O, which is X over H, which is 13. Okay, so we're going to take the sine of 58. Well, the sine of 58 is 0.848, and that's equal to X over 13. And then we're just going to cross multiply the two. So our decimal, 0.848 times 13, and we get that X is equal to 11.02. So about 11, which makes sense because this side cannot be more than my hypotenuse, which is 13. Okay, moving on, 48. So 48 says to find the surface area of this figure. All right, we know the surface area formula is 2 parentheses length times the width plus the width times the height plus the length times the height. And so all we got to do is plug these things in. Okay, so here we have 6 is the length, 4 is the width, 3 is the height. All right, and so we've got 2, 6 times 4 plus 4 times 3, because 3 is the height, plus 6 times 3. Okay, so now it just goes to a simplification process. So we have 2, 6 times 4 is 24, plus 4 times 3 is 12, plus 6 times 3 is 18. So if we add all three of those up in our parentheses, we get 54. So 2 times 54, which will give us a total of 108 for our surface area. All right, surface area is always in units squared. Okay, 49. 49 is talking about the volume of a cylinder. Okay, so the volume formula for a cylinder is pi r squared h. Okay, so we're going to use that. The thing to make note of here is that our r value, r is only halfway, across the circle, so halfway is just going to be 3. All right, so our formula is going to be 3.14 for pi times r, which is 3 squared, times h, which is 10. So 3.14 times 9 times 10. We multiply all three of those together. All right, 3.14 times 9 times 10. We get 282.6. And that's for the whole cylinder. Okay, but what you notice is here we only have half the cylinder. So what we're going to do is we're going to take this and we're going to half it. We're just going to divide it by 2. All right, and once we do that, that's going to give us a more accurate number for our volume, which is 143 units cubed. Okay, last one, we're supposed to find the volume of this sphere or a globe. So the volume formula is 4 pi r cubed divided by 3. All right, and so here we do have 4, which is our r value. So we can say 4 times pi times then 4 again to the third power all over 3. All right, and so we're going to take 4 times 4 times 4, which is 64. So we have 4 times 3.14 times 64, because 4 times 4 times 4 from our 4 cubed is 64. All right, so we're going to multiply everything on the top. All right, we should get 803.84, and then we're going to divide that by 3 to get the volume of this circle. And we get 267.946 repeating. All right, and volume is always measured in 3-dimensional units, so it's going to be units cubed.